right here, we kind of came down to the graph the continuous function g, which is the derivative of the function f. So that's kind of a helpful connection because, as you mentioned, they give you all this information about g, and then they start asking you about f, and it really doesn't make any sense. So that's kind of your key to connect those two. And again, if anything else comes up through these discussions, please don't hesitate to say something. So these are all the answers. Here's the question. Okay, so I think, with A, oh, come on. There we go. A says if f of 1 equals 3, what is the value of f of 5? So here's the thing we got to remember.
I should know how to set it up.
Sure. Based on this wording right here, g is the derivative of f. We could say that g is f prime, right? And so maybe you wrote that down. If you didn't, I think it's worthwhile to just write, hey, g equals f prime. They're the same thing. So here's the deal. I am thinking this, and there's going to be some subtle points in here. I'll try to say them well. If I'm looking for f of negative 5, but if most, if not all, of the information I'm given is about f prime, what tool will I have to use? It's going to have to be an integral. And here's going to be the way that I choose to present this. And this is kind of like you said, wasn't sure where to start, right? So I would go integral from negative 5 to 1 of f prime equals f of 1 minus f of negative 5. I'm sure you understand why I did the antiderivative of f prime. Why would I pick negative 5 and 1? Yeah. And that's that old saying, like you just said, that we've said it so many times. I've got one of them, and I want to know the other one. So this right here is actually a pretty lovely expression for the fundamental theorem of calculus. And so that's kind of where I like to start with this one. So here's where I would go with it. I know from the statement up above or below, f of 1 is 3. That's the one that I do know. F of negative 5 is the thing that I'm trying to get. And then how in the world do I figure out the value of that integral expression on the left? Well, maybe this would be helpful to rewrite it as integral from negative 5 to 1 of g dx. Why would that be so helpful? I've got a graph of g right there. Does that make sense? So then I would say integral from negative 5 to 1. So let's see here. This is a lovely square, right? Right? It's 3 by 3, isn't it? 1, 2, 3, 1, 2, 3. So 9. This is a lovely triangle. It's 1 by 3, so that would be 1.5. This is a lovely triangle also, but it's 1 by 2, so area of 1. So this would be negative 9 minus 1.5 plus 1 equals this. And then hopefully I would correctly use a little bit of algebra and arithmetic to solve for f of negative 5. Remember from practicum, you could do this. Check this out.
Yeah, I was trying to remember what we did.
Watch this.
That's it?
You could just do that. And this is no calculator, and so not only would I say you could do that, I think I would completely advocate for you to do that. How many times have you done something like negative 9 minus 1.5 plus 1 minus 3 and messed it up?
Every time.
My hand's up. I mess it up every now and then, and I should be perfect at it, right? Most of the time I get it right, but every now and then I have a weak moment. I'm like, oh my goodness, 9 plus 3 is not 11. It's 12, right? And so that's why I would advocate for you just to do something like that. Anyways. Oh, I thought spring break would be enough for that to die down. And
I was hoping so.
Shoot. Too bad. Okay. So, Bailey, have I answered your question well enough? Okay. Guys, anything else on A, B, C, or D? Anything else? This is where we dig deep and you hopefully do awesome. But if you mess up, this is where you say, I don't understand why we split B up, or I don't know. So,
So, for D.
Yep.
For an inflection point,
Mm-hmm.
it was only at 4, right? Why wouldn't it be any parts like from -5 to 2, -2 and -1 to 0, like, or 1 to 3? Is that all?
Yeah, so you bring up, I'm not going to spend a whole lot of time on this. You bring up something that was like actually highly, highly controversial at the reading, as well as on the little teacher board, the online little community thing that we have. So let's start with this. Wouldn't it be fair to say that F has an inflection point wherever F prime goes from increasing to decreasing, or where F prime goes from decreasing to increasing? So right here is a clear point where F prime goes from decreasing to increasing, right? So that's why 4 is your inflection point for F. But people brought up the idea that F prime goes from increasing there
Yeah, like that.
to
That was-
decreasing there. Now, this seems to be happening over the course of not just a single point, but is that worthy of discussion as well? So there was a bunch of heated debates, like math nerd fights and other various entertaining things that I choose to just observe. There were some accommodations given to some folks that did mention some things about that. The fact that it says inflection point
Was that the, yeah.
is kind of what sums it up for me. We're looking for a single point, and there is no one single point where this transition happens for that particular interval. But you bring up an excellent question.
It feels like an absolute value graph or inverse of it, and it was going from increasing to decreasing at that point.
Sure.
But
That was a graph of F prime you're describing, let's say?
Yeah. But that,
Would F still have an inflection point?
yeah, if it was like
Yeah.
a chart.
Totally. So I think what Nick is describing is, what if you had a graph of F prime that did this and that? Obviously, so this is a graph of F prime. Obviously, we have one of those sharp looking points, right? Would this be a place where F has an inflection point? Yes, definitely. Now, is F double prime defined right there at that sharp point? Is F double prime defined? No, it is not. But F is definitely defined. And not only is F defined, we can say for sure that because F prime is continuous, F is differentiable.
Mm-hmm.
So this is one of those piecewise graphs that if we anti-differentiated it, we'd get a nice smooth curve.
Okay.
But when you start differentiating it, those piecewise start to break apart. And that's what this is. Yeah. Good question. Anyone else? So really, really good questions. Okay, cool. So we'll try to sneak in as much of this other one as we can. Let's take a look at it here. Number 4. This one is a little bit more of a story question.
I love you say calculus. Doesn't have the same thing.
Let's see here.
Just say cal.
I just don't think people want to do it.
There we go. Okay, so that table is T years and H of T meters. So it says the height of a tree at time T is given by a twice differentiable function H. H is measured in meters, T is measured in years. Selected values of H of T are given in the table above. And then it asks 4 questions. Okay, so here are the answers for these. Here's, I think, A and B and a little bit of C. So there's A right there. So if you can't differentiate, that's fine. Just use the slope of the secant line, right? That's what A is all about. So the answer would be 5/2 for that estimate, and then interpreting that to be the rate of change of the tree's height in meters per year at time T equals 6 years. And as you guys know, all throughout the year, I've definitely tried to be a stickler on these kinds of things. And you can see where it's expected here. They wanted to know the meaning of it with the correct units. So in meters per year at time T equals 6 years, rate at which the height is changing All those elements are in place there hopefully for you. B, the average slope was 2. So since it's a continuous and differentiable function, mean value theorem tells us that, yes, indeed, there is a place somewhere on that interval where h prime is 2. So any questions on A or B? Yes, ma'am.
Why is the interval 3 to 5?
Why is the interval from 3 to 5? I don't know. Let's find out. So they say, explain why there must be a time t from 2 to 10. So 3 to 5 is within that interval. So in order to show that h prime has to be 2, we just need to find 2 data points between which the average slope is 2. So I could have done 3 to 7, except the average slope there would be 1. So that would not fit what I need. I could have done 5 to 10, but the average slope there would be 9/5. So I was looking for any points, any sub-intervals within the bigger interval where the average slope was 2, and 3 to 5 was that little sub-interval. So we just had to kind of hunt that one down. That makes sense? Anna?
Yeah.
So if you found like a spot where the slope equaled 1 and then a spot where like the slope equaled 3, wouldn't that show it because it says it's twice differentiable?
Then you have to bring in the IVT
Has
thinking,
to
right?
go.
Sure. And then you'd say, well, 1 is less than 2 and 3 is bigger than 2, therefore by the IVT, because it's a continuous function, like you said, you could go that way. Yeah, absolutely.
Oh, you can go?
Totally. So yeah, so if you said between here and here the average slope is 1, between here and here the average slope is 3, that means between those, somewhere in between there, the average slope would have to be 2. And if the average slope has to be 2, then somewhere in between, somewhere on there, the instantaneous slope has to be 2 as well.
Okay.
Yeah, that's a little harder to navigate that because there's a lot more wordings you got to consider, but you could definitely do it for sure. Was that yours? Okay, cool. All right, yeah, that's. I think that's some outstanding thinking. I think I have definitely no issues with that at all. Okay, so I know we're up to our time here. C. C, trapezoidal sum. You see the nice evidence for the trapezoidal sum right there. And then the average value would be 1/8 of that. And Bailey, now that I think about it, I think you lost your 1/8.
Yeah.
Yeah. But like what was brought up by several of you, on these no calculator FRQs, it would be so much better, so much smarter for you to leave your answer just like that. Don't simplify it. We all know that you can do 2 plus 6 and 6 plus 11 and all that stuff, but there is no compelling reason to do it. There are many compelling reasons to not.
So that counts as an approximation?
Yeah. So right here, if all you wrote down was the blue box, you would get evidence of a trapezoid sum. It's all right there. And that approximation is equivalent to 263 over 32. So yeah, I would stop right there. I would not move past that at all. D.
Who knows that that's 65.75 in their head?
Say again?
You down?
So D was related rates. You had to do DDT of G of X. You got 2 whole points for that. And then you plugged in the appropriate values. I mean, this was a straight up related rates question, essentially. Apparently, it works out to be 3/4 meters per year at when the tree is 50 meters tall. I am reading faces here, and I'm seeing varying levels of confidence. Heather, I didn't say everybody was like bursting with confidence, varying levels of confidence. Some of you seem very confident, others are a little bit less. Here's the bottom line. Whether your confidence level is up here somewhere or down here or somewhere in between, the cure for whatever it is that ails you is more quality practice. So we're going to do that all week. You need to be doing at least, I would say you need to be at least doing 1 FRQ, if not 2 per day. It's about a half hour of investment. You need to be doing that each day to get yourself ready to go for Friday. Okay? It's good to see you guys.
Good to see you.
Have a good rest of your day.